Today we will do the topic divergence of a vector point function. Let f be any differentiable function. F is differentiable function, means differentiation is possible. Then divergence of f is written as div of f del dot f. It is not del f, it is del dot f, means curly f by curly x dot I, curly f by curly y dot j, and curly f by curly z dot k. Okay, clear? Divergence is always a vector point function and del dot f is a scalar point function. Clear? Okay. Now, how can we find the divergence of f? Let f be any function, some function with I, some with j and some with k. Okay. We have to find divergence of f. That is del dot f. This is not del f. Del dot f. Del dot f means I dot curly f by curly x, okay, plus j dot curly f by curly y plus k dot curly f by curly z. Firstly, curly f by curly x means f1 with x, f2 with x, f3 with x. Okay, j dot with y, f1 with y, f2 with y, f3 with y, and same as z. Now I will do dot product. I dot I is 1, so it will become curly f1 by curly x. Other terms are 0. J dot j is 1, curly f2 by curly y and curly f3 by curly z. This will become div of f, means divergence of f. Next is solenoidal vector. A vector is said to be solenoidal if and only if divergence of f is 0. Then dot f is 0, then it is known as solenoidal vector. And what is curl vector of a vector point of a function? How can we find the curl of f? That is del cross f vector. If this is del dot f, dot for divergence and c for cross and c for curl, d for dot and d for divergence. If we have to find divergence, we will do dot del d dot f vector. And if you find curl of f, c for c start with curl start with c and cross starts with c. You can link it as del cross f is I cross curly f by curly x plus j cross curly f by curly y and k cross curly f by curly z. This is vector. Curl f is also known as rotational vector. Rotational of a function f. Okay. Curl is always a vector point function and del cross f is a vector. Del dot f is a scalar and del cross f is a vector. And how can we find curl f? We have f1, f1i, f2j, f3k. This is f function. I, j, k determinant method. Curly by curly x, curly by curly y, curly by curly z. f1, f2, f3. And what is irrotational vector? If curl of f is 0, then it is irrotational. And if div of f is 0, then it is solenoidal vector. Okay? Clear? Next is, what is Laplacian operator del square? Del squares mean del dot del, and it is defined as del square curly square by some function with x square, double differentiation, partial double differentiation, firstly with x, then with y, and then with z. Okay, it's called Laplacian operator. Del square. If del square is a scalar operator and del is a vector operator. If f is a scalar point function, then del square f is like this, it is scalar, and if f is a vector point function, then it will be a vector. And what is Laplace equation? If del square f is 0, this equation is known as Laplace equation. Okay? What is harmonic function? A function satisfies Laplace equation. And what is Laplace equation? That is del square f is 0. If a function satisfies this equation, then the function is known as harmonic function. Clear? We have to prove that div of r is 3. Okay. Firstly, we will prove that. But let's suppose that r vector is xi plus yj plus zk. Okay. What is div of r? It will become I dot curly r by curly x plus j dot curly r by curly y plus k dot curly r by curly z. Okay, I dot. we will differentiate r with x, we will get I, clear? J, we will get j, and with respect to z, we will get k. I dot I is 1, j dot j is 1, k dot k is 1, then div of r is 3. And we will use this as a formula. In some other question, we will use this formula. Next, we have to prove that curl of r is 0. Let r vector is xi, yj, zk. How can we find the curl of f? Curl of r? There is a formula, determinant method, I, j, k, curly by curly x, curly by curly y, curly by curly z with x, y and z. Okay, I. We will differentiate this, curly z by curly y minus curly y by curly z minus j, curly z by curly x minus curly x by curly z, and with k, curly y by curly x minus curly x by curly y. Okay. Z with y, it will be 0 because we can't differentiate z with y. So all the terms will be 0. J, it will be 0, and with k, it will be 0. So we will get 0 minus 0 plus 0, that is 0. This we have to do. You have to find div of f vector and curl of f vector. And what is f vector? F vector is grad of x cube plus y cube plus z cube minus 3xyz. What is grad? Curly by curly x of x cube plus y cube plus z cube minus 3xyz with I, curly by curly y of this same function with j, and curly by curly z of same function with k. Clear? Okay. When we differentiate this with x, we will get 3x square minus 3yz with I, 3y square minus 3xz with j, and 3z square minus 3xy with k. Firstly, we will find the f function. Now, we will find div of f. What is div of f? I dot curly f by curly x, j dot curly f by curly y, and k dot curly f by curly z. Okay. I dot curly f by curly x, we will get 6x with I, with x we will get minus 3z with j, and vx we will get 3y with k plus j dot. Now we will differentiate with respect to y, we will get minus 3z with I plus 6y with j minus 3x with k. Now we will differentiate this with respect to z. With z we will get minus 3y minus 3x plus 6z. This is I. This will be I minus 3x with j and 6z with k. Clear? And this is dot here. Clear? Now, I will do dot product with I only. It will become 6x. These two terms are 0. J with j, 6y, and next is 6z. Clear? You will get the answer 6 common, x plus y plus z. This will become div of f. Clear? Now, we will find the curl of f. What is curl of f? Curl of f function. I, and firstly curly by curly x, j curly by curly y, and k curly by curly z. With I, this is 3x square minus 3yz, 3y square minus 3xz, and 3z square minus 3xy. We will solve this differentiation. With I will get, with y differentiation, it will become minus 3x. And now this with z, minus minus plus 3x. Clear? With j, minus j. With x, I will get minus 3y. Now with z, plus 3y plus k. Differentiate this with respect to x, we will get minus 3z. And this with y, I will get plus 3z. And it will become 0. Okay? 0 vector. So curl is a 0 vector and diff is 6x plus y plus c. We have to find f cross del cross g. Firstly, we will find del cross g. Clear? Okay. What is del cross g? It will be I curly by curly x, j curly by curly y, and z curly by curly, k curly by curly z. Okay. Ith coefficient 3xz, 2yz minus z square. It will become, we will differentiate with y 0, we will differentiate with z 2y minus j 0 minus 3x, and k 0 minus 0. It will become 0. Clear? Okay. So, and it will become minus 2y with I plus 3x with j plus 0. Now, next we will find f cross del cross g. Cross we will find with determinant method. I, j, k. First function is, we have find f is x, z square, ith coefficient, jth coefficient and kth coefficient. Now del cross g, this function, ith coefficient, jth coefficient and kth coefficient. What is I? It will become 0 plus 9x square z minus j, 0 minus 6xyz, and with k, it will become 3x square z square plus 4y square. This will become del square f cross del cross g, 9x square z with I plus 6xyz with j and plus 3x square y z square plus 4y square with k. Now we have to find this thing at points 1, minus 1, 2. At points 1, minus 1, 2, f cross del cross g. Then it will become 9, 1, 2 with I, 6, 1, minus 1, 2 with j, and 3, 1 square, 2 square plus 4 minus 1 square with k. It will become 18i minus 12j, 4 3s are 12, plus 4, 16k. This will be your answer. Next is evaluate curl of f. Here f function is yx plus yz with I, zx with zy with j, and xy plus xz with k. Now we will find curl of f function. It will become I, j, k, curly by curly x, curly by curly y, curly by curly z with yx, yz, zx, zy, xy, xz. Now, I with, we will differentiate with y, it will become x, and z, it will become minus x minus y. Minus j, with x, I will get, firstly with y. Now we will get x, differentiate with x, we will get y plus z, and this with z minus y. And with k, so with x I will get z, and with y I will get minus x minus. It will become minus yi minus zj minus xk. Yes, this is curl of f. Okay, now we will find curl of f. I, j, K curly y curly x curly y curly z minus y minus z minus x. Then it will become I with, we will get differentiate this with 0 and this will become z 1. It will become 1 minus j. Then minus 1 minus 0 and with k. It will become x with 0 and 1. Then answer is I plus j plus k. This is curl of f. Clear? Example is a vector is given to you and we have to prove that it is irrotational but not solenoidal. So a vector is irrotational if curl of A is 0 and vector A is solenoidal if div of A is 0. So we have to prove that it is irrotational, therefore we have to prove that curl of A is 0 and it is not solenoidal. So therefore div of A is not 0. So A vector is given to us, therefore firstly we will find curl of A vector. So curl of A vector we will find with determinant method, curly by curly x, curly by curly y, curly by curly z upon 3x square y, x cube minus 2yz square, 3z square minus 2y square z. This is, we will find curl of A. Then it will be I curly by curly x of x cube minus 2yz square curly of curly y with 3z square minus 2y square z minus curly of curly z with x cube minus 2yz square minus j, and same we will prove with the help of this. Curly of curly x with 3z square minus 2y square z minus curly by curly z of 3x square y plus k vector curly by curly x of x cube minus 2yz square minus curly by curly y of 3x square y. Okay? Okay, now the answer will be, it will be with y, it will be minus 4yz plus 4yz with I minus 0 with j and k with I will get 3x square minus 3x square. So each term is 0. Therefore curl of A is 0. Therefore A vector is irrotational. Now we will find div of A. What is div of A? Curly by curly x of 3x square y plus curly by curly y with function with j and curly by curly z function with k. So this will equal to 6xy minus 2z square and this will equal to 6z minus 2y square, which is not equal to 0. Therefore A vector is not solenoidal. Clear? This we have to prove. Next is find the value of constant A so that this vector is solenoidal. Vector is solenoidal, therefore div of f is 0. Solenoidal, therefore div of f vector is 0. Curly by curly x of x plus 3y plus curly by curly y of y minus 2z plus curly by curly z of x plus az is 0. This means 1 plus 1 plus a is 0. So a plus 2 is 0. So therefore a is equal to minus 2. This is the value of a. Phi is given to us and we have to find del dot del phi. Del phi, phi is 2x cube y square z4. Del phi, that is, we will convert constant into vector. So ith term with curly by curly x of 2x cube y square z4, j with curly by curly y of same thing x cube y square z4, and k with curly by curly z of 2x cube y square z4. Okay. If we will get 6x, it will become I with 6x square y square z4, and j with 4 x cube y z4, and k with 4 to the 8 x cube y square z cube. This is del phi. Now we have to find del dot del phi. This means we have to do curly I curly by curly x plus y curly by curly j curly by curly y plus k curly by curly z dot I with 6x square y square z4 plus j with 4x cube y z4 plus k with 8x cube y square z cube. This. In dot product, we will multiply ith coefficient with I, jth with j, and kth with k. I will get curly by curly x of x 6x square y square z4, curly by curly y with 4x cube y z4, and curly by curly z of 8x cube y square z cube. Now, I will differentiate this with respect to x. Then I will get 12xy square z4 and 4x cube y4 and 24x cube y square z square. This will be the answer. Now, A is a constant vector and we have to find div of r cross A and curl of r cross A. What is r vector? Let's suppose r vector is general vector xi, yj, zk. And A vector we will assume that a1i, a2j and a3k. Now firstly we will find r cross A. It will be I, j, k, r, x, y, z, a1, a2, a3. Then it will become ya3 minus za2 with I, and za1 minus xa3 with j, and xa2 minus ya1 with k. This is r cross A. Clear? Okay. Now we have to find div of r cross A. Okay. Div of r cross A means curly by curly x of r cross A plus curly by curly y of r cross A. Okay. So I will do ith term with x, jth term with y. Ith term means ya3 minus za2 with x, curly by curly y, za1 xa3, and curly by curly z xa2 minus ya1, and this is 0. So therefore div of r cross A is 0. Okay? We have to find curl of r cross A. What is curl? I, j, k, curly by curly x, curly by curly y, curly by curly z, and term is ya3 minus za2, and this is za1 minus xa3, and this is xa2 minus ya1. Now with I, with y, curly by curly y with of this, I will get minus a1, and with z I will get minus a1 plus minus j. We will get with x a2 minus plus a2, and with k I will get a minus a3 minus a3. Okay. This is minus twice a1i minus twice a2j minus twice a3k. I will take 2 minus 2 common, a1i plus a2j plus a3k. And this is a vector. Then it is twice of a vector. And this you have to remember every time. Dim of r cross a is 0 and curl of r cross a is minus twice a vector. You will use this result in some other questions. Next we have to prove that del square x upon r cube is minus 2x upon r4. Okay. Firstly we will use what is del square x upon r square. This is curly square curly x square plus curly square upon curly y square upon curly z square of x upon r square. I will write it as curly square by curly x square of x upon r square. Okay, curly square of curly y square x upon r square, curly square upon curly z square of x upon r square. I will find these terms separately. So firstly I will find this, then this, then this and substitute the values in term 1, equation 1. Okay. For this, for double derivative we have to find curly by curly x of x upon r square. Clear? Okay. I will use the quotient formula, product formula curly by curly x of 1 by r square into x. First term as it is, differentiation of x is 1, then x as it is. Now I will differentiate this r power minus 2. It will become minus 2 r power minus 3 and curly r by curly x. This is 1 by r square minus 2 x upon r cube. What is curly r by curly x? I have r as xi, yj and zk. R square is x square plus y square plus z square. Then differentiate with respect to r. So twice r curly r by curly x will be 2x. So curly r by curly x will be x upon r. And curly r by curly y will be y upon r. So curly r by curly z will be z upon r. These formulas you have to remember. You will use this formula directly. And curly r by curly x is x upon r. So you will get 1 by r square minus 2x square upon r4. This is curly by curly x of x upon r square. Now I have to find curly square. So curly square by curly x square of x upon r square. Now I will differentiate this again with respect to x. So this will become r minus 2 upon r cube curly r by curly x. And this I will use again product rule. I will get 1 upon r4 as it is. Differentiation of x square is 2x and x square as it is. Now I will differentiate this. It will become minus 4 upon r power 5 curly r by curly x. Curly r by curly x is x upon r minus 2x upon r. It will become r4 twice 2x upon r4 and this will become 4x square upon r5 and x upon r. Clear? Now I will solve this. This will become minus 2x upon r4 plus and minus 4x upon r4 plus 8x cube upon r cube. And this will become minus 6x upon r4 plus 8x cube upon r cube. This is r, I think it is r5. This is r5. This will become r power 6 and this is r power 6. This is curly square of curly square by curly x square of x upon r square. Now I will differentiate this with respect to double differentiation with respect to y. Okay. Curly of curly y of x upon r square. Okay. Here x as constant. So I will differentiate only r. This will become 2 by r cube and curly r by curly y. This will become minus 2x r cube and y upon r. And this will become minus 2xy upon r4. Now I will again differentiate double differentiate this term. Now minus 2x will constant and curly by curly y of y upon R4. Now I will use quotient rule here, or you can use product rule as it is. If you get quotient product rule, first term will be as it is, differentiation of y is 1, y is as it is minus 4 upon R5 and curly y by curly r by curly y. This will become minus 2 1 by R4 minus 4y upon R5 and curly r by curly y is y upon r. This will become minus 2x 1 by R4 minus 4y square upon r power 6. Okay. Now, similarly, I will use curly square, curly z square of x upon r square. I will change y as z, but rest remains same. It will become minus 2x upon 1 by into 1 by r4 4z square upon r6. This is double differentiation with respect to z. Okay. Next is we have to prove that div of u plus v is div of u plus div of v. What is div of? That is del dot u vector plus v vector. What is del? Del is I vector curly by curly x plus j vector curly by curly y plus k vector curly by curly z of u vector plus v vector. Clear? Dot. Clear? Now I will do dot product of this firstly with u and then with v. So I will get I dot curly by curly x of u plus v plus j dot curly by curly y of u vector plus v vector and k dot curly by curly z with u vector plus v vector. Now I dot curly u by curly x plus curly v by curly x plus j dot curly u by curly y plus curly v vector by curly y plus k dot curly u vector by curly z curly v vector by curly z. Now you will get I dot curly u by curly x plus j dot curly u by curly y plus k dot curly u by curly z plus I dot curly u by curly x v curly v, this is v vector, j dot curly v by curly y plus k dot curly v by curly z. You will get this as div of u plus div of v vector. And for curl, you will replace what is curl of u vector plus v vector. Simply replace dot as cross. Rest of the steps remain same. You will get curl of u vector plus curl of v vector.